Welcome to another lecture on engineering mechanics. Today we will solve some numericals on moment of a force. So let us start with the first numerical. Let us read the statement. A force of 800 Newton acts on a bracket as shown. Determine the moment of the force about point B. So over here one bracket is given in the problem. In this bracket there are two points shown. One is labeled as point B and second is point A. This bracket is hinged to a wall, let us say at point B, and at point A one force is applied at an angle of 60 degrees and the magnitude of that force is 800 Newton. And we are asked to find the moment because of this force about this point B. Now, in the previous lecture on moment of a force, we learned that moment m is equal to force into perpendicular distance. Perpendicular distance is between the line of action of the force and the moment center. And we call that perpendicular distance as moment arm. So over here, we have the magnitude of force. If we can find its moment arm, then we can easily find its moment about point B. Now one way is that I should draw the line of action of this particular force, and from this point I should draw a perpendicular onto that line of action. Then we should find that moment arm. But over here the dimensions which are given to us in this problem, these dimensions will not be useful for finding that particular moment arm. So it means we have to see another method. So over here we will apply Varignon's theorem. So what we will do, we will resolve this force into its components. So from this starting end of the vector, we will draw one component along x direction and second component along y direction. Then what we will do, we will first find moment because of this horizontal component about point B by using this moment arm. Then we will find moment because of this vertical component about point B by using this moment arm. Then we will add those two moments to get the moment of this particular force. So this is what we have learned under Varignon's theorem. So let us first resolve this force into its components. So let us first draw its horizontal component from the starting end of this vector, and let us name this as fx because it is acting along x direction. Then from the same point we will draw the second component in vertical direction and we'll label it as fy because it is acting along y direction. In the previous lecture we learned about how to resolve a particular force into rectangular components. So if there is some confusion, you can watch that lecture first. So let us first find these two components. So this component will be equal to fx is equal to 800 cos 60 because we are considering the angle of this force with this component. So this component will be cos component and other component will be sine component. And the value of this component will be equal to fy equal to 800 sine 60. So let us write these two values first. So we'll write components of 800 Newton are fx is equal to 800 cos 60 and fy is equal to 800 sine 60. We will find the values of these two components. Now after this we will apply Varignon's theorem. That means we will first find the moment of this particular force about point B, that is the moment center. So for that force we have to first find the moment arm. So how to find moment arm? Very easy. We will first sketch the line of action. Then from moment center we will drop a perpendicular onto that line of action. So this particular distance will be the moment arm. So let us find where this distance is given in the diagram. You can see this distance is given over here as 160 mm. It means 160 mm is the moment arm for this particular force. So let us first find moment because of this particular force. So how we can find? We have to multiply the magnitude of this force with its moment arm. So we have already found its magnitude as 400 Newton. So when we will multiply 400 by its moment arm, we will get its moment about B. So after finding the magnitude of moment because of this component about B, we have to also see what is the nature of that moment. In the previous lecture on moment of a force, we learned that whenever we have to define a moment, we have to define two things, that what is the magnitude of the moment and what is the nature of the moment. In that lecture, we learned that clockwise moments should be taken as negative and anti-clockwise moments should be taken as positive. So now we'll see what type of moment this particular force will generate about point B. Now you see this particular force is acting towards right. And one very important point to understand over here, that when you want to find the moment because of any particular force, then we will not focus on the direction of the force. Means we will not say that it is acting towards right, so let me take this positive, or it is acting towards left, let me take that as negative. No. While calculating moment, we don't see the direction of the force. We just see whether the nature of the moment is clockwise or anti-clockwise. If the nature of the moment is clockwise, we will take that as negative moment. If the nature of the moment is anti-clockwise, we will take that as positive moment. So let's ignore its sign because of the direction of the force. Let us just see what is the nature of the moment produced by this force. In the previous lecture as well, I said that in order to find the nature, what we should do, we should find the closest path which a vector should travel in order to reach to the moment center. So closest path of course will be this. If we will see this path, there will be a longer path, so we will not consider that. So closest path is this. It will try to move towards moment center. So in this process what will happen, it will generate a clockwise moment. So we know we have to consider clockwise moments negative. It means moment because of this component about B will be equal to minus 400 multiplied by 160. Similarly, let us see the moment because of this component, that is Fy, about point B. So let us first find its moment arm. So in order to find its moment arm, what we will do, we will sketch its line of action first, which is a vertical line. Then from moment center, we will drop a perpendicular onto that line of action. So that is called moment arm. So let us see where is the length given for that moment arm. So that is given over here as 200 millimeters. It means for force Fy, moment arm is 200 millimeters. So moment generated by this component about point B will be given by 692.8 multiplied by 200. So that is the magnitude. But now we have to see the nature of the moment produced by this particular component. So in order to find its nature, we have to see the closest path. You can see that if we consider this path, so this is the closest path which this vector can travel to reach to this moment center. Fine. But if it travels in this manner, that is the longest path. So we will not consider that. So closest path is this. So in this process, what will happen? It will again generate clockwise movement. So clockwise movements are negative. It means movement generated by this particular component is a negative moment. So final answer will become minus 692.8 multiplied by 200. Then we will add moments because of these two forces, and that moment will be the moment because of this resultant, that is 800 Newton. So let us see in the calculations. Now you can see over here we have written moment because of 800 Newton force about point B is equal to sum of the moments generated by these two forces. So we have written minus Fx into D minus Fy into D. Why minus? Because both the moments are clockwise and we have to take their sign negative. So let us put the values minus 400 into 160 minus 692.8 into 200. So let us solve this now. Then you will get value minus 202560 Newton millimeters. Fine. So you can convert this into meters as well. That will become minus 202.5 Newton meters. Now over here you can see we got negative sign for the moment generated by this force about point B. So negative sign means that this particular force will generate a clockwise moment. So I hope this numerical is clear to you. Let us move on to the next numerical. So let us read the statement of next numerical. A foot valve for a pneumatic system is hinged at B. Knowing that alpha is 28 degrees, determine the moment of the 60 Newton force about point B by resolving the force into horizontal and vertical components. So over here in this diagram, one figure is given to us, and this is an image of foot valve, and this valve is hinged at point B, and there is another point A on which 16 Newton force is applied at an angle of 28 degrees to the foot valve, because alpha over here is given in the statement as 28 degrees. And the angle which this foot valve makes with the horizontal is mentioned as 20 degrees. Then we are given distance between points A and B as 170 mm and distance between point B and C as 80 mm. And we are asked to find moment because of this force about B by resolving this force into its components. That means we are asked to apply Varignon's theorem. So let us apply Varignon's theorem now. It means what we have to do, we should first resolve this force into its components. Now how to resolve this force into its components? We have two choices. Either we can pick this point or we can pick this point in order to show its components. So let us pick this point to show its components. So what we will do, from this point we will draw one line along the lever and second line perpendicular to the lever. But one very important point to understand over here is that when you have to resolve any force into its components, first of all we have to decide axis. We have to decide x-axis and we have to decide y-axis. So what we will do in this figure, we will consider x-axis along the lever and y-axis normal to the lever. So now what we will do, from this point or from the tip of this vector, we will draw one horizontal line, that means along the lever, because we are considering x-axis along the lever. Then we will draw one vertical line, means vertical to the lever, that will be along y direction. So let me show those two components now. So you can see over here we have drawn two lines. After drawing those two lines, we have to represent their direction. So how to represent their direction? We have to focus on the direction of the vector. We have considered this as origin and vector is pointing towards the origin. So in these two lines also, we will show the direction pointing towards the origin. Fine. So this is acting along x direction, means along the lever. So we are considering this as fx, and this is acting perpendicular to the lever, that is along y direction. So we are considering this as fy. Now let us find the values of these two components. So as we have taken 28 degrees as the angle between the force and this component, so this component will be called as cos component and another component will be called as sine component. So value of this component will be fx is equal to 16 cos 28 degrees and value of this component will be fy equal to 16 sine 28 degrees. Now over here one very important point to understand, when we are dealing with the moment of a force, means we are dealing with problems in which we have to find moment, then in those problems we don't consider the sign of the forces, means we have found their magnitude as 16 cos 28 degrees, 16 sine 28 degrees, but we will not consider their direction. Fine, because we have to just find the moment because of these two forces, and in case of moment we just see nature of the movement. If the movement generated by any force is a clockwise movement, then we consider that movement as negative, and if the movement generated by any force is an anti-clockwise movement, we consider that movement as positive. But we don't focus on the directions of the forces or the components for positive or negative sign. So this you should keep in your mind whenever you are solving any problem on movement of a force. So let us show the calculations now. So components of 16 Newton force will be Fx is equal to 16 cos 28 and Fy will be equal to 16 sin 28. We have found their magnitude. Now you can see we are not considering their direction because we are solving a problem related to moments. Now what we will do, we will find moment because of these two components about point B. Now one very important point to understand. When you will find moment because of Fx about point B, then you will see that perpendicular distance between this component and moment center is 0 because this particular component or the line of action of this component intersects with the moment center. So moment arm is 0. So we can say moment because of this particular component will be 0. So we are only left with this component. So if we have to find the moment because of this component, we have to first see its perpendicular distance from the moment center. So the perpendicular distance of the line of action of this force from moment center is mentioned here as 170 mm. So we'll multiply this moment arm with the magnitude of this component. So that will be the moment because of this component about moment center B. Then we will see the nature of that moment. Now you see, if we have to find the shortest path of this vector in order to move towards moment center, then that path will be this path. So in this process, it will generate what? It will generate anti-clockwise movement. So movement because of this component will be anti-clockwise and we'll consider that as positive. So let us see this in calculations. Now you can see over here moment because of 16 Newton force about point B will be equal to the sum of the moments because of these two components about the same point B. So we are applying Varignon's theorem. Over here you can see we are using this component Fx over here, but its moment arm is 0 because its line of action intersects with the moment center. Plus y plus because moment because of this particular force is an anti-clockwise moment, so we have considered plus over here. Its magnitude that is 7.51 multiplied by its moment arm, that is 170. So from here we will get our answer. Now you can see the final answer is positive. It means the moment generated by this particular force about point B is an anti-clockwise moment, so that is why we got positive answer over here. I hope this numerical is also clear to you. Let us move on to the next numerical on moments. A 300 Newton force is applied at A as shown. Determine A part, the moment of 300 Newton force about D. So let us solve it part by part. So first of all, let us solve A part. So what we are asked to find in A part, we have to find the moment of 300 Newton force about D. So let us understand this particular diagram first. So in this diagram, one rectangular body is shown to us and this body is hinged at point D as shown in this figure. And we are given another point A at which 300 Newton force is acting at an angle of 25 degrees with the horizontal. And we are asked to find its moment about point D in the A part. So some dimensions are also labeled in the diagram. So these dimensions will help us to locate the moment arm. Now in order to find its moment about point D, what we need? We need its magnitude and we need its moment arm. So how to find the momentum? What we can do, we can first sketch its line of action, and from moment center we should drop perpendicular onto that line of action to show the moment arm. Now this perpendicular is the moment arm for this particular force. Now look carefully over here. Can we find this moment arm from the given dimensions? No, we cannot find this moment arm from the given dimensions. It means we cannot apply this direct method. It means what we have to do, we have to take the help of Varignon's theorem. That means we will resolve this force into its components, horizontal and vertical components. Then we will find the moments because of those two components. Then we will add those moments to get the moment of this force about point D, which is the moment center. So let us first resolve this force into its components. So how to resolve? It is very easy. This is the vector given to us. 2 points are there, starting point and the tip. You can choose any point to label the vectors or the components of this vector. So let us choose this tip. Then from that tip, draw two lines, one in horizontal direction and one in vertical direction. You see, two lines are drawn over here. Now, in order to label the direction of those components, let us see the direction of this particular vector. Now you see the direction of this vector is towards origin. So when you will draw two lines here, then direction of those two lines should also be towards origin. So we have labeled the horizontal component as fx and vertical component as fy. So now we will find the moments because of these two components first. So let us first see moment because of this component. So in order to find the moment of this component about D, we need to find its magnitude first, then its moment arm. So let us first find its magnitude. Its magnitude will be equal to Fx is equal to 300 cos 25 degrees. Why? Because the angle of 300 Newton force is taken as 25 degree with this component. So this is a cos component. So that is why its value will be 300 cos 25 degrees. If this is a cos component, then other component will be sine component. It means value of Fy will be equal to 300 sine 25 degrees. Now, bache, again I am repeating the same point. When we are solving a problem on moment of a force, we don't find the direction of the components. Means we don't label positive or negative sign. We just find their magnitudes. Because in the problems related to moments of a force, we just see whether a moment is clockwise or anti-clockwise. Accordingly, we consider the signs. Now let us show the values of these two components in the calculations. You see fx is labeled as 300 cos 25, fy is labeled as 300 sin 25. So we have calculated their magnitude and we are not considering their direction. Now let us first find moment because of this particular force or component fx. How to find the moment of this particular component about D? For that we need its magnitude and its moment arm. We have already found its magnitude. Now we have to find its moment arm. So how we can find the moment arm of this particular force? First of all, draw its line of action. Then from moment center, drop a perpendicular onto this. So this is its moment arm. Now let us search the length of this moment arm in the dimensions given to us. You can see this line is placed over here as well. It means its dimension is how much? 200. So moment arm for component fx is 200. So we will multiply 271.89 with 200 to get the magnitude of the moment because of this component. Then we will see whether that moment is a clockwise moment or anti-clockwise moment. Now you can see this is the moment center and this is the direction of force. So if you have to trace its shortest path, then this will be the shortest path towards moment center. So in that process, it will generate what? It will generate anti-clockwise movements. So we have to consider its movement positive. Now let us focus on next component, that is Fy. In order to find the moment because of this component about moment center, what we need to do, we need its magnitude and its moment arm. Its magnitude is already calculated by us. It means now we have to find its moment arm. So how to find its moment arm? First of all, sketch its line of action, and from the moment center drop a perpendicular onto that line of action. So this is its moment arm. So let us search the dimension of this moment arm in the diagram. So see, this dimension is placed here as 100 mm. It means moment arm for this particular component is 100 mm. So if we want to find its moment, that will be equal to 126.78 multiplied by 100 mm. Then we have to search whether that movement is a clockwise movement or an anti-clockwise movement. So for that, what we need to do, we have to see the direction of that component and the movement center, and we have to see the shortest path. If this component wants to move towards the movement center, so this is the shortest path. So it means it is a clockwise movement. So clockwise movements are negative. So we have concluded that movement because of this component will be a positive movement because it will generate anti-clockwise movement, but the movement because of this particular component will be a clockwise movement and it will be a negative movement. Now let us see this in calculations. So moments about D due to Fx and Fy are, so you see the magnitude of Fx multiplied by its moment arm. So we have taken this as positive because it is generating clockwise movement, plus movement because of other component. We have already found movement because of other component is a clockwise movement, so that is a negative movement. See, over here we have entered negative sign. So multiply its magnitude by the movement arm, then that will be the movement of second component about point D. Now let us solve this further. So we'll get the movement of 300 Newton force about point D. So it is 41699.5 Newton millimeters. So you can give answer in Newton meters as well. It's your choice. Now let us solve the B part of this particular problem. So in B part, let us see what we have to find. We have to find the smallest force applied at B that creates the same moment about D. Okay, let us see how we can find it. But before that, let us understand very important point about smallest force. So we have the formula of moment as F into D. Now in this particular B part, he is saying the smallest force applied at B, which we have to find, that creates the same moment. What is the same moment? This moment. So what he wants that left hand side of the equation, that is moment, should remain same, that is same moment, but on the right hand side force should be minimum. So if you want to keep movement same and you want to reduce force to minimum, then we have to increase this to maximum. Only then left hand side will be equal to right hand side. So let us see how we can increase movement arm to maximum when we will apply force at point B. So let us first connect these 2 points OB, and this is the movement arm, I should say, if we want to apply force at B and if we want to keep that force be minimum, because for minimum force we need maximum moment arm. So how can we use this complete length as the moment arm? We can use this complete length as the moment arm if we draw force at B at 90 degrees to that moment arm, because we know that we can consider only that distance as a moment arm which is perpendicular to the line of action of the force and to the axis of rotation. Fine. It means we have concluded if we want to apply smallest force at B, then first of all we have to connect DB, and in order to make dB as the complete moment arm, we have to show our force 90 degrees to that moment arm. Only then this force will be minimum. So in order to find the value of this particular force, we will use this equation now. We have this value, same moment, which is 41.69. Now we have its moment arm as well, that is dB, which we have to calculate now. So if we can calculate its moment arm by using mathematics, then we can easily find this force. So let us first find its moment arm, that is dB. So how we can find dB? We can find its moment arm through this triangle. In this triangle, the hypotenuse is dB, perpendicular is a length of 200 mm, and base is a length of 200 mm. Now you can see these two lengths, base and perpendicular, both are of same length. It means these two angles are of 45 degrees. This is 45 degrees, this is 45 degrees, and this is 90 degrees. So over here, if we want to find dB, we can say sine 45 degrees. That means perpendicular upon hypotenuse is equal to sine 45 degrees. And if we want to find hypotenuse dB, that will be equal to perpendicular divided by sine 45 degrees. Fine, you can see over here dB equal to perpendicular, that is 200, divided by sine 45. So from here we can find the moment arm. This is the one method. Second method is you can apply Pythagoras theorem, because we know perpendicular, we know base, and we want to find hypotenuse. You can find through Pythagoras theorem. So once the moment arm is known to us, then we will use this formula m is equal to fb into dB to find the minimum force required at B to generate same moment about B, that is 147.37 newtons. Over here one point you should understand that we are taking moment at D in Newton meters. We have used this value, and the value which we have calculated over here is in millimeters. So I have converted that value into meters, because I have used the units for moment as Newton meter. Fine. But if you will use this particular value for the moment, then you can use this value for moment arm. So you have to be very careful about the units you take while solving problems. So I hope this numerical is clear to you. Thank you very much.